Hello friends, welcome to Sekho. In this video, I am going to talk about motion in a straight line. Motion in a straight line. And in this video, I'll define what is motion, then what is position, how do we define position, then what is path length, what is displacement, what is average speed, and then what is velocity, average velocity. So first of all, what is motion? Motion is a change in position with time. If an object changes its position with time, then we say that object is in motion. Okay, so motion is change in position. Change in position with time. This is motion. Now, what is position and how do we define position of an object? Okay, so to define position of any object, first of all, what we have to do, we have to define a reference frame, and a reference frame is either on axis and a point, or a point and two axes, or a point and three axes. Let me elaborate it. If a particle is bound to move in a straight line, then we can define that particle's position just by an axis, okay, by a straight line. But an axis or a straight line is not sufficient. We also have to take a point as reference. So this is a point, reference point. So if we take a reference point and an axis, then we will be able to define the position of a particle that is bound to move in a straight line. So if the particle moves in this straight line, we can, maybe that particle is in this position at some certain time, then we can just get it by maybe we have to define unit length. Maybe this is 1 meter, this is 2 meter, this is 3 meter, this is 4 meter, and then this is 0.2 meter. Okay, so the position of the particle can be found like 4.2 meter. Okay, if we say that position of the particle is 4.2 meter, then we will understand that we have to move in the positive direction and we have to move 4.2 meter. That is the position of the object or of the particle. So this is how we can define a particle's position in one dimension. If the particle is moving in a two-dimensional space, for example on this whiteboard, then we can define its position. Maybe the particle is moving and its position at a certain time is this, and now we have to define its position. So what we have to do, we have to take two axes perpendicular to each other. We are taking two axes perpendicular to each other. This is our reference point O, and maybe we are defining this distance as 1 meter. So this is 1 meter, 2 meter, 3 meter, 4 meter, and this is maybe 4.5 meter, and along y axis we have to, this is x axis, let us say this is y axis, we have to go along y axis maybe 1, 2, 3, 3.5, 3.5 meter. So the position of the particle can be defined like 3.5 meter and 3.5 in this direction, 4.5 meter along x and 3.5 meter along y. 4.5 meter along x and 3.5 meter along y. If we write like this, 4.5 meter comma 3.5 meter, we will just be able to find this position. So in case of three dimension also, we have to take just three axes perpendicular to each other. This reference frame that we are taking here is called we call this type of reference frame uh, Cartesian coordinates, but there are many other coordinates. We can choose many other form of coordinates or references, but this is the most convenient one. Okay, so but our target in this video is motion in a straight line, so I will not talk about motion 2 dimension. Sorry, this is not for erasing the board, this one is for erasing the board. Okay, so now we know that what is position and how we can define position in one dimension. If it lies in this direction from 0 to in the left side in this direction, we call this positive direction and we call this negative direction, then it is just 2 unit negative. So minus 2 meter, if we say minus 2 meter, then the position of the particle is minus 2 meter, then we know that from the reference point 0 we have to go to this left side towards left 2 meter, and then we will get the particle. Okay, so this is how we can define the position of the particle. And here this is interesting that, okay, so now let us talk about path length. If the particle moves along positive x direction or negative x direction in one dimension, so let us say this is moving in this direction, let us say this is 100, this is 200, this is 300, 400, 500 meter, 600 meter and 700 meter and so on. Okay, and in this direction this is 200, this is 100 meter or whatever you can choose. Now a particle starts from this point, reference point O, and it moves towards this direction, and at first it moves to, let us say, this point P, which is 300 meter, and then it moves from P to Q up after that. So at first it moves from O to P and it takes some time, let us say. Now, and then it moves from P to Q. So what is the path length it is moving? The path length it is moving is just 300 meter plus from this point to that point. This is also 300 meter. So it moves 600 meter total. Okay. Now if the particle moves in the negative x direction, let us say it moves again this much, it comes back to R, this is position R, so it moves back 200 meter, this is 100 meter, this is 200 meter, so it will be added again 200 meter. So total path length is 3, 6 and 2, 800 meter. So path length is just added irrespective of the direction it is moving. But if we are considering about displacement, then what will happen? In the first case, if the particle starts from O to P, then just displacement is 300 meter. It is moving in the same direction, x direction. So the displacement also will be 300 meter. Then if it moves again from P to Q, it moves extra 300 meter and it is still moving towards the right direction or positive x direction. So again we have to add this, so meter. So now if the particle starts from O and moves to P, then P to Q, its displacement also becomes 600 meter. But if it moves back, maybe it moves back to R, then it moves in the negative x direction. So what we have to do is we have to just subtract this distance. So the net displacement will be 300 plus 300 meter plus 300 meter minus 200 meter. So it will be 400 meter. So displacement and path length is different thing. In case of displacement, we have to consider its direction also. but in case of path length, we just don't consider its direction. Path length does not have any direction, but in case of displacement we have to consider its direction. So displacement is, if we say that it started from O and it moved to P, then P to Q, then Q to R, what is the displacement? You just have to take the initial point and the final point, and you have to see how far it is, 100, 200, 300, 400. So displacement is 400, and along the x direction you have to also here mention that along the x direction, or you can just write 400 meter without saying along the x direction. Why? Because here there is only two sides, two directions, this direction and that direction. So if we consider that this direction is positive and that direction is negative direction, that means if we get positive value, we will consider that it is along the right direction, positive x direction. So we don't have to explicitly say that along positive x axis. We just can say that displacement is 400 meter and positive x direction will be automatically mentioned. Even if you don't say it, it is actually understood that it is in the positive direction. Now if the particle moves from R to, maybe this is let us say T, R to T. So what is the displacement? You have to just consider this initial position and that final position. How far it is? 100, 200. It is 200 meter away, but in the negative x direction. So it will be minus 200 meter. So it means that it is 200 meter away and it is in the negative x direction. So this is how the displacement and path length are different. In case of path length, you just add all the distances that the particle moves or the object moves. But in case of displacement, you have to consider the direction, in which direction it moves. If it is in the positive x direction, it will be added. If it is in the next negative x direction, it will be subtracted. So you have to consider the direction also in case of displacement. Actually displacement is a vector quantity, and you will see what is vector quantity and more about vectors in chapter 4. So we'll discuss about vector in detail in chapter 4. Okay, so path length is a scalar quantity. It does not have any direction, but displacement has direction. It is a vector quantity. Now what is average speed and what is average velocity? So if I ask you that what is the average velocity between average speed when particle moves from O to P, what will you do? You just have to take this much path length. What is path length here? Here path length is 300 meter. Okay, here path length is 300 meter, and if the time given to you is maybe 10 seconds, then the average speed will be speed is 300 meter by the time taken from to travel from O to P. So those 10 meter. So it will be 10 second. So it will be 30 meter per second. Okay. Now particle can move faster when it started, and it can become slow in the middle, and then again it can become faster and then stop. Or it started slow, then it gained velocity, then again it became slower and finally stopped. Whatever, it started at this point and it stopped at this point or maybe it didn't stop, but we are considering this 2 point. So from this point to that point, what is the time it has taken by what is the distance, and then what is the time it has taken. We have to just divide it and we will get the average speed. Now what is the average velocity when particle moves from O to P? Average velocity means we have to take the displacement. Now O to P, this is in the positive x direction is not being changed, so displacement will also be 300 meter. Displacement is also 300 meter and it has taken 10 second. So it has taken 10 second. So average speed, average velocity is also this 30 meter per second. But when I am saying velocity is 30 meter per second, there is a notion that it is in the positive x direction. But in case of this, when I am saying average speed, it does not actually say anything about direction. Whether it is moving in the positive x direction or not, it is not saying anything about that. Okay. Even if the particle moved in the negative x direction 300 meter in 10 seconds, then also it would have been 30 meter per second. There would be no negative sign. Okay, in case of average speed, when you will find average speed, because path length does not have any direction. Now if we consider that particle moved from this point to that point, now what is the average velocity and average speed? In that case, let us say from P to Q, it took 15 minutes, 15 seconds. So the total distance traveled is, that means total path length is 600 meter, and then total time it took is 10 second plus 15 second. So this is 600 meter by 25 second. So it would be like 2 and 4, 24 meter per second. Okay, it would be 24 meter per second. And now what would be average velocity if we consider the particle moved from this point to Q? Then it will again be 600 meter by 10 second plus 15 second. So again it will be 24 meter per second, same thing, but it has an inner meaning that it's in the positive direction when we are doing average velocity. Now when the particle moved from this point to that point, again back, then the displacement become only this much, but the path length becomes how much? 600 plus 200 back. So the path length in that case becomes 800 meter, and let us say it took 10 seconds to come back from Q to R, 10 seconds again. So the total time taken is 10 seconds from O to P, then P to Q again 15 seconds, then again Q to R, it took how much? It took 10 seconds. So total time taken is 35 seconds. So the average speed in that case will be average speed will be equal to how much? It has path length 800 meter by 35 second, whatever it is, maybe this is something like that, 160 by 7 meter per second. Okay, so this is the average speed But what is average velocity? When particle started from O, then it moved to P, then P to Q, then Q to back R. What is the average velocity? In that case, actually, what you have to consider is the displacement from O to R. What is the displacement? Its displacement is just 100, 200, 300, 400 meter. 400 meter displacement is 400 meter. Displacement meant equal to 400 meter. How much time it took? It took 35 seconds. So the average velocity would be, velocity is equal to 400 meter by, average velocity would be 400 meter by 35 second. 35 second. So this is what the velocity, and see here you can calculate displacement in another method also. For example, when it moved from O to P, you just write OP, okay, in the positive direction. You have to add all these displacements. So OP is positive displacement. How much? 300 meter. Then P to Q, how much? 300 meter again. It is also positive, 300 meter. Then Q to R, it is negative. So it will be minus 200 meter. So it will be 400 meter. You can think like that, or you just can think that in case of displacement, you have to think what is the how far the final point is from the origin. It is just 100, 200, 300, 400, and this is also 400. Okay, so this is how you find displacement. So guys, in this video I have explained to you what is motion, and then what is position, how do you define position in one dimension. I told you little bit about two dimension also, but that I will elaborate in the next video. Then I talked about path length, what is path length, then displacement, what is displacement, and then what is average velocity. Average velocity just is equal to path length by total time that is taken by the particle to travel that much path length. Then what is average velocity? Average velocity is displacement by time required to make that much displacement. So guys, if you like this video, please hit the like button. If you think these videos are helpful to you, then you can subscribe this channel. And if you think that this video is not helpful to you, but it may be helpful to some school going people or maybe some other people, then you can share this video with those people. So guys, thank you for watching. I'll see you soon in the next video.